Okay. All right, this seems to be the sweet spot. I reduced the quality of OBS's output stream because I'm running at 1080p, so that's really high. But I think this might be the sweet spot where my CPU usage maxes out at around 85 when I'm running OBS and my application like this, my debugger like this. So I think this should be okay. And I think the code should still be legible, so I'm going to run with that for now. See how that goes. If anyone has a problem reading this code, do let me know, and I'll see if I can figure out a way to make this work better. Okay, so last time I was working on my emulator, I had implemented add, subtract, and add with carry, which I still don't know for sure if they're implemented correctly, but we'll figure that out. And I was using this online emulator, which I think might have a bug in it, or I just don't understand why it was behaving so strangely. When I would run the compare command, it was updating this overflow flag in a way that didn't seem to make sense to me. So I've actually written to the author of the tool, and I'll see if he writes back and what he has to say about that, if he writes back. He may not. But in the meantime, I'm going to keep focusing on the emulator here. So I think if I disable trace and just let it run, yeah. So this is what I was getting yesterday. I get this unmapped address, and the reason why it's an unmapped address is because the address that we're trying to read, D800, if we look at the memory map, yeah, falls into what's known as illegal. It's an illegal section. Now technically it's illegal, but what it is that it's actually both, it maps to both VIA and RAM at the same time, which is basically means that these address lines, if you address here, the address lines go to both the VIA here and the RAM here. It selects both, which is probably a bad idea and unlikely to be a valid case. I mean, unless it's a bug, but more likely there's something wrong with the way my emulator is processing the instructions. Either what's happening is that, you know, we're running in some kind of loop incrementing a variable, because I know this comes from an inc, and maybe we're not hitting, like maybe we're supposed to, you know, get some kind of feedback, some kind of result from hardware, maybe from the VIA, and I haven't implemented it yet, and so it just keeps incrementing past what it normally would in real hardware, and then we end up accessing out of range. So that's one possibility. And it kind of would make sense maybe that we are incrementing and maybe addressing in the range of RAM, eventually going through VIA here, which is very small, and then eventually hitting this illegal range. So that's what I'm suspecting. The problem is that it takes too long to run with the debugger output like this. So what I was thinking, and I don't want to disable the trace because I lose too much information. So my thought, I was thinking about this earlier, is if I could route the output to a file, I think then I won't pay the cost of the console having to update, and then I can look at the resulting output. So to make that work, what I'm going to do, just give me a second. No. Okay, so what I want to do is create a directory junction, link, and target. Okay. This should be in I have an active Vectrexy. All right. And in here, build 2017 debug. Okay, so what I want to do is, so if I run Vectrexy like this, I need to provide a ROM. It doesn't really matter what I provide it yet, because I'm not even using it, but I'll pass something anyway. So let's go to, I think I have ROMs extracted, scramble, here we go. Failed to open file, all right. It's because I need to run it out of this directory here where the bin, bias ROM bin is. Yeah. So build 2017 debug Vectrexy. So I can just go up one directory then. Scramble. Okay, so there we go. So that basically gets me into my debugger. Just quit that. And now I need to feed it. I need to feed it instructions on standard in. So yeah, what I'm going to do is I'm just going to create a little file with what I want. So I think if I do type input into, let me bring back my Vectrex line. I type it. That's not quite right. Okay, so why did that not work? I think I need to, oh, I probably need to enter a continue. There we go. Okay, so that's, yeah, that's the thing. Doing Control-C doesn't work. Oh, no, I shouldn't have closed that. Okay, try it again. Code active Vectrex call Vectrexy. Okay. So take that, type input.text, and then pass that. Sorry, type input.text and pipe it into this. Okay. Type it and output.text. Okay. So this is good. So this should be running the emulator now and putting all the output into a file. And at some point I should get that assert. And then I can look at what the output looks like. I wonder if hold on a second. It would be cool if I could show the tail of that file. think I could do it with, do I have tail in here? Yeah. So if I do go into E code, active Vectrexy tail output.text. Yeah, so we can see that it's being updated. What is that parameter again? To have tail kind of constantly run. Follow tail-f. Okay. I don't know if that actually slows it down. Probably not. Yeah. So it should be okay to tail it. So it looks like it's still significantly slower to have it output this trace even to a file than just running it without the trace, but it would be good for me to get that assertion and be able to take a look at the log to understand why I'm getting that assert. So I'll just let this run. I had a list here. Okay, this is just my list of stuff I was thinking of doing. So debugger to print memory values. So yeah, this is the idea that I'd like to be able in my debugger to say, you know, given an address, I want to see some number of values, and I would like to also have the ASCII values for each of the bytes printed, so that I can look for certain string patterns and stuff. So there's that. Yeah, this would be really useful. Debugger load and execute a startup script. As you can see, I'm always kind of, in this case, I put it in an input file and piped it in, but I often end up copy pasting little bits of text into the debugger. So it would be cool to have just a little startup script always execute this stuff when launching the debugger. Yeah, so actually this is no longer needed. In the end, it wasn't actually really slow. What was slow was the contention with the CPU, which now seems a lot better since OBS is using less CPU. And we can't base it on this because this is tail, but when I do run it normally now, it's much faster. The debugger here, I said set instruction pointer to address. Yeah, I just need a way to set the program counter, allow me to move it around. Sometimes I execute some code and I want to re-execute it, move the program counter somewhere. So that should be pretty easy to do. Debugger, fix that breaking into debugger displays. So yeah, right now I have a problem where, in fact, I know what the problem is. I was thinking about it this morning. The problem that I have is that here. So when I'm not broken into the debugger, which is the case when I'm running normally, I execute as many instructions as can fit, and I'm doing this where I print the instruction and then check for a breakpoint. So that's one thing I need to fix, is just literally swap the order. Just want to swap the order of this and the breakpoint code. Just make sure that if there is a breakpoint, that we break right away, because when there is a breakpoint, we break out. If we don't break out, in that case, print this. So that will actually fix this bug here. So I'll be doing that. So actually, yeah, because the way I saw it is fix that breaking into debugger displays. But what actually happens is it displays it, then it says, oh, we hit a breakpoint, and then stops, and it's already too late. We've already printed the instruction. But if I move this down here, it won't do that. So okay, just swap print op with breakpoint checks in not broken to debugger loop. Okay. And then finally, catch exception from CPU for unhandled op and break into the debugger. So I actually wrote the code for this already. I'm not super happy with it, and I haven't actually had it happen yet, so I don't even know if it works. But in general, right now I have these cases where I get assertions, and when I get an assert, it breaks right away into the code, which is good. But then the problem with asserts, at least the default ones, is it tears down the whole program. And what I would need is for instead of asserting like that, I either have to write a custom assert that allows me to break into the debugger if I need to, or continue, in which case I could throw something and allow myself to stop in the debugger and look at what's going on. So I got to think about something like that. So let me write some notes here. Custom assert that doesn't kill app. After assert, maybe throw exception for debugger to catch. And what I could do is that these exceptions wouldn't be thrown in the final emulator if that's actually a performance problem, which it probably won't be. Okay, so where are we at here? Still going with this. And how large is my log? Let's take a look. Okay, Vectrex. Oh, it's huge. Already at about 100 megs. Not sure how much longer this is going to run for. Just want to make sure. Yeah. I can see that there's a lot of stuff going on here where it's trying to write to the via ports. Via port A, via port B, via shift register. Just want to see if there's some kind of pattern going on here. Just grab a little bit of this. Okay, so let's see. This address here does not show up again. Okay, yeah. So yeah, I can see if I just focus here on these addresses here. 64. FB14, FB64, FBB4. Aha! Okay, so I hit the assert finally. So now if I abort, there it is. So now I have this huge file, 130 megs. Here it is. Let's see how well Notepad++ handles a huge file like this. All right, not bad. About 1 million lines. It's pretty good. And so we don't see it here, but the instruction that failed was an inc. It was one of these ones, the inc u instructions. I know that because if I run it like this, and here, let me just do that, trace disable, and then just run it. You see, I hit my assert much more quickly if there's no trace. And what it is, it's trying to run is this increment right here. Yeah, it's an increment. So actually, I don't know for sure which increment it is, but I said this one, but it, inc a increment accumulator. Yeah, so it's got to be an increment of some address in memory, and I think this would make sense. D800. Seeing as, yeah, we're like super close here. So it's really, it's this. Yeah, let's see what all of these look like. Oops. Damn it. Hit home by accident. So I gotta go back to the end of the file. Okay, back to this guy. So yeah, we can see that we're in this loop where we want to branch if less to here. And interestingly, we are doing a compare, and that's exactly the instruction that I was looking at yesterday, worrying about overflow not being set correctly. So what does branch if less look at? Let me just double check that. Okay, so it's not less. It's branch if lower or same, and in that case it looks at the carry. So it carried if we're lower, or 0, which means we're same. Okay. So what are we doing here? Okay, so we get to this point here. So the loop begins like too many lines of code here. Yeah, Notepad++ is pretty good, but it's not perfect. Okay, yeah, it starts here. Okay. Again. Okay, so let's go up. Okay. So here is the very first. C858. So Vec explosion 1. So I believe what I saw yesterday was that this code is related to audio. I'm just going to double check now. I'm going to go look at the bias source code that I have. .6ca. Yeah. It's this init music routine. And this value that we're writing here, or incrementing here, okay, load u C858 vec expl 1. We can go take a look at what that is. So just bring the BIOS to the end here, and as well as the inc file. Let's see if we can line this up with the code that we have here. All right, 4 bytes copied from explosion sounds ureg parameters. Four bytes. So that's, I guess they're talking about these four. 1, 2, 3, 4. 4 bytes are copied from explosion sound. Explosion sounds ureg parameters. U register parameters. What are we talking about here? What is explosion sound? It's this here. Explosion sound F9 2E. 2 e. 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 2 F92E. Just check something in the memory map. C800, C800. So yeah, these addresses are really in the range that are used by the BIOS. So it looks like this explosion sound thing is like something that the Vectrex would provide. Like if you want a generic explosion sound, it comes built in, the BIOS can provide that for you. That's the impression I'm getting, which is interesting. Okay, so what is this here? Let's see if I can find a jump or a jump subroutine. Here it is. I think what I'm going to do is I'm going to copy from here downwards into a new file, because this way I can do searches and stuff more easily. Alright, so this is the init music. And another thing I want to check is there another such call in the output? 882. Yeah. 5,925. To find all in current document. Interesting. So we actually jump to the init music fairly often. So then that makes me wonder, what's the difference between, let's say, the last one, which is where we crash, and say the time before? So this is at line 1146431. This is 41286. So let's diff the two. Let's open up a beyond compare. Do a text compare. And I want to select from here I can't do that kind of selection. Can I do like mark in here? Begin and select. There we go. So copy this. So this is one that didn't fail. And let's compare it to this last one here. So from here downwards. Okay. So quite different, right from the very beginning, where we see that the value in here is different. So the value that it's loading into A, here it had the value 80 in hex, whereas this time it had 1. This is branch if minus. Yeah, branch if minus to F6B3, which it did not go. So because the value loaded into A here was positive, whereas here is negative. So that's interesting. So maybe that's the difference. Well, anyway, it is a difference. Seems to make all the difference. Shift minus. So this is an offset of 28. Why? What is this about? What is it expecting at init music at this vec music flag? Okay, this means a bit was set, right? This is some kind of flag. Let's go take a look in here. Aha, music active flag, off, start, on. So I bet this is the first time where we call init music and it's actually turned on. Maybe that's what's going on here. And that's why we're exercising different code. Because here it was start, and then here it's on. So somewhere the vec music flag got set to on, and then when this init music chk got called, this time it went into a different piece of code. I just want to make sure, I want to check all instances of this call here, this line, to see if like we see 80 only being set once, what the rest looks like. So we come back to the output, find all in document with this address. Okay, actually, I'll do that again, but with the square brackets so that we can see just the calls, just the lines of instructions. Yeah, here we go. So here we see zeros all the way down, and then at the very end, 1 for start, and this to say that it's on. Okay, so that explains the divergence. Okay, so basically the music wants to be on. And I'm sure we can see that in the code here. Let me reread what this function is. So these routines are responsible for filling the music work buffer while a sound is being made. It should be called once during each refresh cycle. If you want to start a new sound, then you must set C856, that's the one we're looking at, to 1, and point the U register to the sound block. So it means I want to turn it on, I want to start playing the song, this music, and you will point to where that sound is. If no sound is in progress, 0, then it returns immediately. Okay? Unless you called init music or init music DFT, which do not make this check. Right, okay, so this is init music with a check. Otherwise, you can just call init music, or I don't know what the DFT stands for yet. All right. When a sound is in progress, C856 will be set to 80, as we are now looking at. These routines process a single note at a time and calculate the amplitude and coarse fine-tuning values for the 3 sound channels. The values calculated are stored in the music work buffer at C8-3F to C8-4C. C8-3F. Really? Here we go. Music work buffer. So we'll be looking for vec music work. $14 bytes backwards. Okay. Yeah, 4C. So this is the range. No, sorry, including this one. Music data format. So the header word C8, C8-4F. No, so the header word is C8-4F. It's just a value. 32 nibble ADSR table. Eight-byte twang table. So it's saying if this is there or if this is there. So if this is the value, then it means 32-bit nibble ADSR table. Otherwise, it's an 8-byte twang table. So I'm not quite sure what these means. This means yet I need to read more about audio for the Vectrex, but it's okay. And then it's followed by the data bytes. That's how the music is stored in memory. The ADSR table is simply 32 nibbles, 16 bytes of amplitude values. Ah, okay. Okay, I see. So basically it's 32 4-bit values for amplitude values. The twang table is 8 signed bytes to modify the base frequency of each note being played. Each channel has a different limit to its twang table index to keep them out of phase to each other. Okay. Entry DP C8. So it says the direct page should be set to C8 or will be set, I'm not sure. Okay, yeah, it looks like what it means is when you call this, the direct page should be set to C8. Obviously, because all of these are in the C8 range, so that makes sense. I mean, C8 is the memory that the BIOS uses. UReg points to the start of the music data. C84D points to the frequency table. So that's if the DFT this is called. C856 may need to be set. And these guys get trashed. D, X, Y, and U. Okay. So what's going on for us? Actually, I just want to read a bit more of this code. Test that the sound is active. Continue sound if active. So that's what we saw, the branch if minus. So we actually offset to here in the case where we crash. Get address of ADSR timers. So load U with this value. We should see that in our output. Let me see if I can split this like that. Yeah. Count for 3 channels. Load B with 2. Okay, get the channel's ADSR timer. Okay, so this means read this plus an offset of 2. So timers plus 2. Okay, ADSR timers for each sound channel, 3 bytes. That's why. So I think probably it's going to be reading it backwards because it's accessing first at index 2, and then maybe it'll access at 1 and 0. Let's see. It says count for 3 channels, yeah. Get the channels ADSR. Compare A to 1F. Because we loaded A with that. Branch of equal. Otherwise, else increment the timer. go back for the other channels. Decrement B, yeah, there we go. And then branch if plus back up here. So this should happen 3 times. So let's see. 1, 2, 3, yeah. And then in each case here, it went back to F6B8, except for the last time. Or continued. Okay, that looks good. So now we're at load X. So we're here, the vec_twang table. So we're starting to get closer to the infinite loop. Load U with the vec music twang, which is here. Load A with 7. So twang limit is 6 to 8 depending on channel. Okay. Increment twang counter. Vec music twang. And just see 3-word twang table. Okay, so 3 words. Check against limit. Branch if greater than or equal to here. Otherwise, let me just kill the audio here. Okay. Hmm. Just give me a second. I'll be right back. All right, sorry about that. Okay. So what I wanted to see, so what is this code trying to do here? Saying load X, load U with the music, Vec music twang, load A with 7, reading this code will make your eyes go crooked. Okay. Try to understand the code here. So compare A here. What this means is take the value that we loaded into A, which is 7 in hex, and compare it against the value in U, which we are incrementing, and U was set to Vec music twang, which I don't understand. Oh, okay, A. That means that we're checking it means that we're checking the high byte 07. Is that what that means? No. What happens when you compare? Oh no, so that's it. Yeah, that's what I don't understand here. We are putting A into here, and then we are saying compare A against the value at U. Okay, we can see it here. Vec explosion 1. Compare 8 to 9 here. Go back until all 3 channels are done. Branch if less back to here until we get to deck. Okay. To decrement here, vectration, and branch if not equal. So let's see here. It looks like we're getting stuck in this loop for this does not look right. Yeah, this is totally where we're stuck. There's something wrong here. F6cc, just compare here, increment, and branch back to F6ca, branch of less to F6ca. It's this here. We're doing this over and over and over, starting from here. And it all gets primed up here, so I need to understand what this code is doing. Hey man. Hey Fred, welcome to the stream. So yeah, I'm just trying to figure out, I have this loop here that goes on and on at one point while running the BIOS, and I end up getting an assert because it isn't breaking out of this loop, and therefore eventually gets to a point where it tries to access memory that's out of legal range. So I'm getting much closer now. Trying to understand what's going on here. It's in this init music function here. So it's init music with a check. So what I've determined so far is that at the point where we are getting this assert, the BIOS has loaded up a song to play, and then it's saying, okay, now we're playing it, and it's going through the part where it's loading the data it needs to start playing the music. And I get to F6ca here, this increment twang counter. So yeah, I'm just trying to understand what's going on here. So what is this supposed to do? So this thing called a twang table storage for second music header word, twang table. So that up here, load X, C851 twang table, yeah, that's it. Which had the value FE in it. Then we load U with vec_expo1. And here's as twang limit is 6 to 8 depending on channel. So I put 7 in hex here. And it says increment the twang counter. So here it's taking the value that was in U and incrementing what it at that address at C858. which here we can see, yeah, it was 0, and then the next time that it actually gets read, it's 1. And that's the compare here. So we're comparing that value to A. Okay, so that's it. It's going from 0 to 1. And we want to see if it reaches 7. So Fred says that symbol resolution on C858 looks different between the disassembled copy of the code versus yours. Vec Music Twang versus Vec Explosion 1. So let's see here. So let me see. C858. Yeah, that's the problem. Yeah, so the problem is that there's two values mapped to the same address. And so when I'm loading symbols for my debugger, unfortunately, I'm getting, I'm overriding this address with a second value I read. Yeah. Yeah, you have a good eye though. That's totally true that's confusing. Like I'd want it to be this here right now, right? Just so that in this specific case. So I guess they're kind of like using this address to have two meanings in the code. Yeah, I don't know. I guess I could detect, like have a multi-map, and if I see if there are, like I could print all the values for a given address. This way, it's more accurate. It's like this or this or this. I don't know how often that would happen. It'd be interesting to parse it and see. I'll just make a note. I have my little to-do list somewhere here. Here. Load symbols. Multi-map of address to values. So some are mapped to the same address. Okay. So back to this BIOS here. Okay, so let's say that's the same. So that's it. We're putting 7. We are going to be using U here. So that's it. So we read the value there, and here Vec Explosion 1 got 0, then it got 1. Branch if greater to this, which it is. So branch if greater than or equal, which means that how does it work again? BGE. Okay, so it's greater or equal if negative XOR overflow is equal to 0. So as long as both are 0 or both are 1, no, sorry, as long as XOR is basically true if they're both different. Yeah. Sorry. Gotta drink so much when I'm on stream. Just a second. All right. Yeah, I think I got this from the book that I'm using to implement stuff. It's like a trick. So actually, it's interesting because yesterday I was looking at yesterday I was implementing compare. I mean, that's actually where my bug might be, because we're using compare here, and in fact we're using compare A, and like I have this difference between the way my overflow flag gets set versus this emulator that I'm using to compare. Let's see if I can show it to you. So yeah, yesterday so I found this pretty cool online assembler where you can choose, like, it supports all these different CPUs. So the 6809 is in there, and it's running an emulator and everything. And so what's cool is that, I thought, hey, I can use this to compare. Yeah, it's really cool. And I thought, I can compare and actually see, you can save your files and all that. It's all local though, like you don't need an internet connection, just it downloads. I think it's running JavaScript or something. Not even sure what it's running. But anyways, and so here I wrote this test yesterday, and there's something really funky. And I don't know if it's a bug in this emulator or if it's a bug on my end. But the funky thing is this. Subtract and compare, right? Compare is basically supposed to be like subtract, except we only care about the flags and how the flags are updated. So, and I mean, even when I look at the description of subtract and compare, the section on how the flags get updated are exactly the same. And it even shows that compare is basically saying take a value in your register and subtract the value in memory, and then whatever the flags, like update the flags with the result, and discard the actual result of the subtraction. And here's the thing. So what I was looking at was the case of 0 minus 1. Nice and simple. So here, when I do 0 minus 1, it gives me -1, as one would expect. So that's negative. It's non-zero. Overflow is not set. And then the carry flag is set because no borrow occurred. So basically, carry is set inverse to to borrow. So if a borrow occurs, then the carry flag is not set. Anyway, what's interesting is more this overflow here. There is no overflow in 0 minus 1. At least that's how I understand it. And my code and this code does compute the same thing. I do get this, and it produces this here. But when I do a compare, which should be the equivalent of 0 minus 1, where I load 1 and store that into RAM, load, let's say this, yeah, sorry, load, oh, I was trying different things here. Yeah, so let's say I load 1 and store into RAM, load 0 into B, and then say compare B against what's in RAM. So this is 0 minus 1, and I would expect it to give me this, similar to here, but what I actually get in this emulator is that overflow is set. Yeah, so you're saying 0 minus 1, a carry would occur, right? Which is why carry would be set. Yeah, C behaves correctly. But what doesn't behave correctly is overflow. So I'll show you what I mean. I'll actually simplify this. So I'll just do this, and then I'll do the version here. And I'll just separate them with nops so that we know. Okay. So this is cool. This is the emulator. So you can actually step in. So I loaded A with 0. So there's A with 0. And then I subtract 1 from A, which stores into A the result, FF, right? And then here you can see the flags. And the part that I'm interested in are the last 4 here. So it's negative, non-zero. It says no overflow, which seems correct to me. And then carry set. Now I step, and this time I'll do with a compare. So load A, and I store that into RAM start, so that's at C880. So you can see 1 got stored. I load 0 into B. And I say compare B to RAM start, so that should be 0 minus 1. And just set the flags. And here we go. This emulator says negative 0 overflow and then carry. And my emulator, when I do compare, I just reuse, the same functionality that I use for subtract, but I just don't care about the result. And what's weird too is it behaves this way when I do compare A or compare B. And A and B are 8-bit, like 1-byte registers. And in fact, there is this other register called D, which is a combination, right? It's like basically it's A in the high byte and B in the low byte. So it's like it's a 2-byte or 16-bit register that overlays those two, just like EAX with EAH and EAL. EAX and AL, I think it is, right? I think that's right. But yeah, so that's like 16 bits. And what I was going to say is that, so I have these tests where I was doing the compare test here with A, with B, and then with D. A and B both give an overflow. They both set overflow when they compare, but with compare D it doesn't, which just seems completely strange to me. Like, just to show you there that I'm not crazy, although I am crazy. Yeah, I'll just leave it like this. Compile. Okay, so let's jump to the test compare code. So this is load A with 0 and store it at RAM start, and then do a compare of just 0 minus 0. And that gives what we expect, NZVC. This is the 0 minus 1 case that's messed up, so store 1 there. load B0, compare. We have overflow here. And then just to complete there with D, load 1 into D. And when you load onto the D, you see that basically it cleared A and put 1 in B, because that's the low byte and that's the high byte. I store D, so I'll just show here C880. So right now it has a 1 here, but what's going to happen is that storing this 2-byte value will put a 0, 1, because it's big endian. Correct. Then it's going to load 0 into D, which will clear the B over here. And now I'll do a compare D against RAM start. So this is 0 minus 1, but in 16 bits. And now I get what I would have expected with the other compare instructions, which is overflow not set. So compare D does not behave like compare A or compare B in terms of overflow. This is weird. You agree? Yeah. I was staring at this yesterday. My code doesn't do this. My code does what I think should be right, which is overflow not set. Overflow means there was not enough space in the register to store the result. Right. Yeah. So I actually wrote to the author of this asm80.com. And I'm just waiting to see if he ever writes back. I think he's in like Russia or something. But yeah, we'll see if he says anything. But that's the thing, is it makes me worry, right? Because right now I'm going to keep debugging this, but like if I'm stuck in this compare and it's doing a BGE here is looking at negative or overflow, right? And if my overflow flag is not being computed correctly, maybe that's why I'm getting stuck in here. But I mean I need to understand what this code is actually trying to do to see what's going on here. Okay. So Fred says, I would trust your code more than the online thing. I don't know. I don't know if I trust my own code, to be honest. But yeah, I'm going to keep looking here, try to understand this logically and see what is actually occurring. But yeah, I don't know about trusting my code. Like I've had a lot of stupid bugs in my CPU implementation, and it's nice. It would be nice to have like a reference implementation that I can compare against, but not by like looking at the code, but just by looking at its output. It kind of like feels more authentic. Like if I could, I'd program the actual Vectrex and like debug it, I can't do that. Or maybe I could if I guess if I got one of those, rewritable cards there for the Vectrex. But I could not debug it. I'd have to like, program it to like write values and use the screen or something. It would just be a lot of work. So I just figured I just need to find like a working emulator that does the right thing. So I'm probably going to search at some point for maybe just a Vectrex emulator that's doing the right thing and hopefully has a decent debugger with some trace and stuff, and I'll compare the compare with that one and see what it says. So yeah, so that's where I am at. Okay, so let me see if I can understand this now. Okay, so we loaded 7 in here. So load 7 into A so that we can compare A to the value that U is pointing to. So that's the 0 that became 1 when we incremented it here. So this actually makes U move to the next address, which is why we see U become vec explosion 2 the next time we access it. So let me see here. Because if we had not branched, we would have cleared it if limit exceeded. Okay. So I think this is basically a reset for like the next. It wants to write 0 where U points to once we've exceeded the limit. And I guess this is a limit, yeah. Otherwise, we move U to the next value. Which means that we would 3-word twang table. That would mean it would become this. Yeah, you're looking at the data sheet. I know. What I'm using to help me is this 1980s book that has, it kind of like has incorporated a lot of what the data sheet says. In fact, it basically has screenshots and everything from the data sheet, and then it adds a whole bunch more information. So it's like it's called the MC6809 cookbook. Okay, that didn't work. Yeah, there we go. So this cookbook here, this book is like this big book, you know, and it's got like sections for all the instructions. So this is what I've been using mainly to implement everything. So like, you know, if we look in here for compare, so here, that's the 16-bit version. Okay, so here's the 8-bit version, and you can see like, so it's just saying temp is R minus N, so a register minus the value in memory. And for overflow, it says set if the operation caused an 8-bit 2's complement overflow. So Fred is sharing this Reddit post. Yeah, so overflow occurs when the inputs have different signs, but the result has the same sign as the second operand. Yeah, I think another way to phrase that is if the inputs have the same sign and the result has a different sign, I think. Because that's the way I know overflow. right? Like if you add two positives and you get a negative, that's overflow, and if you add two negatives and get a positive, that's an overflow. Although maybe for subtract it doesn't work that way. Right? Because if I take a positive and subtract a positive, I may get a negative. So for 0 minus 1, your code did set the overflow? No. No, it did not. It does not set overflow. It's because the thing is, the way I implement it, another way to look at how to do subtraction is to do an addition instead. Yeah, so what I said about two positives makes sense for addition, right? If I add two positives and I get a negative, and if I add two negatives and get a positive, that's overflow. For subtraction, I'm not sure that makes sense, but I don't think about subtraction because I just think about subtraction as the adding of the 2's complement, which I've also seen that's how I did my NES emulator, and that's what a lot of people online, and I found the Stack Overflow where someone also talks about doing it that way. So that is what I'm doing. I'm basically doing the 2's complement, and there's actually advantages to that as well, because when you do it this way, it also works out that you can do the add with carry in the same way. So you do the 1's complement plus the carry for the case of the carry, I think, or plus 1 plus the carry to make it a 2's complement with carry. And then that has to happen I do it inside let's say I'm doing an 8-bit subtraction, so I end up doing an add, but into 16-bit values, or anything bigger than 8-bit, so that I can check that overflow did indeed occur. Oh, and sorry, no, I can check the carry occurred, that there was a carry out. But overflow is really just checking that most significant bit, at least in the case of addition. So if I'm right, and that is what I've read, and that's how I did it for the NES, yeah, overflow, you don't even really need to look at, you don't need to have like a larger register. You just need to check the most significant bit of the 3. So the 2 values you're adding and the result. And that's what I do in my emulator. Like I can show you, I have like a little calc overflow. And then I do some little XOR logic that I don't even remember how that works, but it works. Like basically I'm doing an XOR of A with the result and an XOR of B with the result, ANDing those two, and then ANDing with just the most significant bit. And if that's not equal to 0, then an overflow occurred. And then for the 16-bit case, it's the same thing, except the most significant bit is bit 15. So this seems to be doing the right thing. And it's very close to what I had for the NES emulator. This logic does not line up with a comment from Reddit, though. This is, though, about subtraction, right? Like, I think that what I have here works as long as you're calculating overflow for addition. Yeah, for addition, yes. What you said earlier makes sense. Yeah, but I turn it into an addition for subtraction. See, subtract impl, for example, in the case of the 8-bit, is basically calling add with A, the 1's complement of B, and what I call the carry is I put 1 here, and the idea is that add with carry, subtract with carry would be 1 plus the carry flag. And then in add, which is up here, I use a larger value, like a larger size, larger int, and I do a plus b plus carry. So here it would be like a plus the 1's complement of b plus 1. So this is basically an addition, right? And like I was working it out, you know, here in Notepad. Like in the case of 0 minus 1, that's the same thing as, you know, 0 plus minus 1. Exactly. Right? Which would mean no overflow. Exactly. That's right. If it's, you know, basically the 2 bits here, as long as the 2 most significant bits are different, there's no overflow in the case of addition. It's really only when they are the same that there might be an overflow. But according to the Reddit comment, that shouldn't be the case. So, okay, so you're saying in the case of a subtraction, right? So 0 minus 1 is minus 1, right? Overflow occurs only when the inputs have a different sign, but the result has the same sign as the second operand. Ah, so I see what you mean. But this only has 3 points. Yeah, that's the thing, right? Overflow and subtraction doesn't even make that much sense. I would love it to line up with the theory of addition with a 2's complement. Yeah, this guy here says this is actually a pretty non-trivial question to answer, and he points to a Stack Overflow, which I'm pretty sure is probably the one that I looked at. No, it's not even the one I looked at. For addition, any 2 operands will result in at most 1 bit more than the largest operand's highest 1 bit. Okay, so this is the other thing, right? I was going to say is like the word overflow, unfortunately, is like an overloaded word. It has 2 meanings, and here we see somebody using it in the other way, which is to say the bit overflows into the carry, which is really unfortunate, right? Because carry and overflow bits are not the same. So here somebody's asking, I think, about carry. Yeah, it's not at all the same thing. Okay, so back to this. Oh, wait a minute, wait a minute, wait a minute, wait a minute, wait a minute. Positive minus negative, right? That's not this case, right? This is positive minus positive. Because here you can see he's saying, or negative minus positive, right? Yeah, super confusing. So it does line up, right? This is a case where overflow cannot occur. Hey, sedated snail. Sedated snail says maybe one tests for overflow and the other tests for underflow. I don't know. But actually, this kind of makes me feel better because, like, what it's saying here makes sense to me, right? Because, see, it's saying positive minus negative, which is going to be a positive, right? And it makes sense. If we go back to what I was saying, this is basically addition. And if the sign of the result is the same as the second one, in other words, if an addition causes a negative, that's overflow. Similarly, this is a subtraction, minus a positive, right? So this is a addition of two negatives, right? And if that produces a positive, that is overflow. So it all makes sense, it lines up, and I feel better now. So I don't think I'm wrong, and like I said, I think I'm gonna have to look, yeah, I'm gonna have to compare against another emulator that gets it right. It's crazy, like no one gets this right. The page I was looking at is how to implement, I think the one that was add with carry or subtract with carry. Yeah, I think it was this one. Yeah, exactly. This is the one I was looking at yesterday. And like the top answer is like, welcome brave adventurer to the arcane halls of the 6502 add and subtract commands. Many have walked these steps ahead of you, though few have completed the gamuts of trials that await you. Stout heart. So like everyone's like, yeah, it's hard, you know? This other person here, in fact, this other person, this answer has actually more votes, now I see it. And this one here, it talks about how it is, you can use the complement, right? The only thing I don't quite get in this one is he's showing how ADC, like SBC, so subtract with carry, he's calling ADC with a ones complement, which is -1, minus arg -1, and in there adds just the carry. But I think you're supposed to add 1 plus the carry, because you're supposed to add the 2's complement. So even this one seems wrong to me. It's like no one gets it right. I don't know. Anyway. Here, I'll just paste this in here in case anybody wants to look at it. So Fred says he's going to look at how he wrote it for his Game Boy emulator. Then bad. Yeah, I'm actually feeling tired too. I might call it quits soon. Just wanted to stare a little bit more at this code to see if anything stands out. So Fred says the quasi Z80 in the Game Boy does not have overflow. Really? So it has add with carry, subtract with carry, but no overflow. So like when dealing with signed values, you can't know if it overflowed or underflowed? There are only 4 flags on the Game Boy. Wow, okay, interesting. Ah, wait, there is a subtract flag. Can't recall what that's about. Subtract, eh? After the pointer register is used, it is incremented by 1 or 2. Yeah. So Fred says, I have separate logic paths for add and subtract. Yeah, I could do that as well, but in the end, it seems like I can write one in terms of the other. So if I can, I'll try. We'll see. Well, I didn't come up with the idea of using the two's complement. I just kept reading it. I read it in a few different places, and so it seemed like the way to do it. And because I'm not smart enough to like think of how to do it with subtraction, so addition is so much simpler. comp 0 and -1. So Sedated Snail is asking, did I do 0, -1 and compare 0 and -1? Let me check. No. No, I really did load 1 into the, I stored 1 into RAM, loaded 0, and then did a compare. So it's comparing 0 to 1. But yeah, I had actually made a similar mistake yesterday when I was writing my tests, when I was doing subtraction. But yeah, I had put like -1 here, and in fact, it was supposed to put 1, and I was all confused. I think it was when I was trying to do 1 minus 1 minus 1, and I was doing 1 minus -1, and anyway. But no. All right, Fred, thanks for hanging out. Talk to you later. Fred says it's time to try to get some shut-eye in the crushing humidity and heat, and he envies my central HVAC. It does work. I got it all fixed. Thank goodness. But it sucks for you. Hope it's not too bad. Okay, so this gets that 1. It went from 0 to 1, gets the value 1 into B. Masks out the low 3 bits. Update. Okay. Just focusing on here. Compare A to 9. Branch if less to F6CA, which is what happens. Because A gets incremented here, why am I not showing the value of A in my increment? Let me see. This is one of those cases where I need to have oh yeah. Let's see. Okay. I need to add cases for increment and decrement. Usually these are is that right? Yeah, inherent instructions like increment A, compare A. Although compare A here, I wrote 9 because that's the immediate value. That's right. I'm not showing the value in register A. So yeah, I have no idea. So A was loaded with 7. Okay, so it should just be incremented twice. Incremented here, compared with 9. So let's see here. F6DD, F6DD. Huh. That's weird. Load A with 7. we increment it here, we compare it against 9, oh sorry, I was looking at the wrong thing. Okay, branch if less to F6CA. Yeah, keep branching to F. That doesn't make any sense. Let me see. No. Yeah. If I set a breakpoint on this guy, I can see what's going on. Let's do that. Break there. Just get my trusty load symbols, set that flag, turn off the trace, and let's continue until we hit that breakpoint. Okay, turn back trace on. Now, so we load A with 7. So we increment A, became 8. We compare A to 9. So 8 minus 9 is negative. It's not 0, there's no overflow, and carry is set. And the next instruction is branch if ls bls. Take care, Sedated Snail. Thanks for hanging out. Appreciate it. Branch if lower or same. So we're looking at carry or 0. Make sense? We're lower if the carry is set. Right. Yes. So we end up on F6DD here. So branch if less, and we end up at F6CA. Exactly. We've incremented A again. Oh, what happened here? A became 1. This must be the bug. I'm doing something stupid here. I must be trashing A incorrectly. EC. E6. Load of B. C4. 0x C4. And B. Oh shit. Ha! And there we have it. That's it. This has to be B. Jeez. Let me take a look here. Opcodes and B. Oh my goodness. Wow. So basically, ANDing and B was actually ANDing into A, which was messing up the value of A. Wow, okay. That's cool. That is awesome. So let's see. If I just disable trace and just go, let's just see how far we get. Like, is the next thing we hit an infinite loop, or is it an unhandled operation? Definitely running longer than before, so we're probably in an infinite loop. Just let it run for a few more seconds. F33F. Oh, yeah, there we go. Oh, wait a minute. Did I not set the dude register? Oh, what? Oh, yeah, of course. Okay, so still not valid. Turn off the trace. Okay, now we see how long we last. Ah, there we go. Unhandled op, com A. This is great. So that means we made it further and we've made it to an instruction I have yet to implement in the CPU. This is a perfect place to stop so I can work on this next time. But before that, let me just commit what I have. There we go, another bug fixed, another single character fix in the code. But it was fun. It was fun to debug this one. I got to learn a little bit more. Every time I debug these things, I learn a little more about how to read this assembly language. All right. So fix and B incorrectly ANDing the A register instead of B. So I take a look at these changes I've made to the debugger. So what I realize is that I'm calling print op in a few places where I assume trace. That's incorrect. I'm checking here if the trace is enabled, then I do a print op. What I should be doing instead is checking the trace inside print op. Because I don't know. Okay, yeah. That's fine. For now, I'll just do this. I'll refactor that after. Yeah. Now, if I do it this way, and I move this down here, I think this will make more sense. Yeah, so now when I have trace disabled, I just see what address I'm at. I step, it then shows the trace. If I hit continue, it proceeds, yeah, this is correct. Curious how it colors. I must have some weird bug with the setting of the color. Anyway, but anyways, and then if I set the trace off and I hit continue, that's correct. Yeah, I was here. Continue actually shows the output of this instruction and keeps going. And if I set a breakpoint on the instruction I'm on, it will continue. It'll not break on the current one. It'll execute it and then execute the next one and break the next time. Okay, yeah, that's perfect. Okay. So let me look at my debugger changes again. Yeah, I don't like too much how I have this repeated code. I have this here, I have this here. This is not quite the same. The execute's buried in there. These two lines definitely should be, yeah, I'm going to make a local function for that. It's always the same. I'll even call it print op, but it'll take no parameters. A nice little lambda for that. Okay. So I'm calling the print op. That's defined. Oh, does it actually find it? Unnamed print op. Yeah, it does. Interesting. It's interesting because it's not actually in the global namespace, but it's in an anonymous namespace. Seems to resolve though. Yeah, so now I'm getting the problem of it's clashing with this name. Which is okay, because I actually want to call my lambda in here. Yeah, okay. So let's fix this. And this one, this last one here. The only thing I'm wondering about is this, why it's showing the address here in light blue, or cyan, or whatever it is. Light aqua. Ah, this is why. If I'm broken into the debugger, it sets this color as a default output color. Why did I do that? Oh, right, it's because of all of this. It's so that all my commands that are processed when I'm broken into the debugger output a different color. But a side effect is that when I step, but I could easily fix that. I just need to set a color here. Or the address. That's interesting. It's not exactly what I wanted, but it's interesting. Maybe it's not so bad. Otherwise, I guess it would have been light gray. No? Is it white? What does it consider this color? Yeah. Okay, it's considered white. It's a strange white, but okay. Kind of cool having it be a different color. think I like it gray. I don't know why. Just because it helps my prompt stand out a bit more. I mean, it's still legible. Otherwise, what do I have? So limited in colors. What's aqua? Nah. All right, let's go with that. Let's go with gray. What is that? M underscore. Oh. I think I did a search and replace at some point that I didn't want to do. Yeah. Okay, I think this is good. The only thing with trace I don't like is I'd like to have a more generic system for setting values on and off in the debugger, like setting Boolean values or toggling them, setting other values. I mean, for now it's okay. I think I'll keep trace like this, just toggling like this, but I need to generalize this. I also don't like that it's a toggle, that's all it is right now, but it's fine. Toggle, and disassemble, assembly trace. This, yeah. Okay. This is good. I should get that unhandled up. Oh, and actually, that is an exception. That's cool. Because I'm here in my debugger, so if I step it, oh, it actually continues. Why? Why did it continue? F1, D7, and I'm at F1, D8. So my unhandled exception should not actually have continued. Okay, so before I do anything, let me just get some of this stuff committed. mismatched color of disassemble current address when stepping versus now always set it to a fixed color. That print op. Okay, so this became all of this. Just want that part. Oh, hey, Alvaro. Twitch tells me when Twitch friends start watching. That's why I see it says here, your friend Alvaro has just started watching. That's cool. Okay. Yeah, this is not right. No, it's not right. I think my cherry picking lines is not doing the right thing here. Yeah. Okay, yeah, it's because what I need is I need to remove this and keep this, but without the tabs. Do I want this exception code then right away? All right, why not? Just take it all. Okay, so what have I got here? Add trace command to toggle this asm trace output. Also add actually this try catch thing. No, I don't want it. I need to rework it because I need to do it also when I execute. It's not just when I execute when I'm continuing, but also yeah, I want this also when I'm executing instructions here and here. So I'm probably going to want to like factor this into another function. And anyway, it's not time for this just yet. I'll do this as a separate change. Okay. So this looks good. Let's commit that. And I'm just going to go put that code back so that I can think a little bit about how to do it correctly. Need try catch around all calls to execute instruction, like when stepping. And then the other thing I had seen was that even for an unknown instruction, I've already moved the op forward. So just make a note of that. And then that's it. That's it for tonight. CPU when unknown, when unhandled op. Should not advance PC or should reverse PC. Maybe useful. I don't even know if it's useful. When I have an unhandled operation, there's nothing much I can do. So it doesn't really matter. And never mind. Okay. Okay, so I'm going to stop here. I'm just going to push my changes. So thank you everyone for watching. And next time we'll continue plugging away at the CPU. Thanks again. Take care.